penuh bermisi Guru Ayu, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, salam sejahtera dan good afternoon to everyone. Welcome to Pusat Tuisyen Akademi Youtuber with the joint venture of eDidik Malaysia and Guru Malaysia. In the beginning, are you able to hear me? Please respond to me if let's say you can't hear me at the chat room. So I am Mr.Peh. Currently, I am teaching at College Tingkatan 6 Tun Fatimah, Melaka. I am the teacher on duty for this week. In this afternoon, we broadcast live from my channel, Cikgu Peh channel. For those haven't subscribed my channel, please press the subscribe button to show you are supporting to me. Today, we are going to continue our subtopic of Chapter 5, where the subtopic we are going to learn today will be 5.3, refraction of light. So in this subtopic, we are going to learn about 4 learning standards. In this week, we have 2 physics classes where the Form 5 physics will be presented by Cikgu Izyan. And now we are at subtopic 5.3, transistor. And for Form 4, will be today's 3:30 p.m. And as mentioned, we are going to continue the subtopic of Chapter 5, 5.3. Okay, so without further ado, okay, so let us start our class today. So before we go to our Learning Center 1, so let us recall some of the knowledge you already learned in Form 1. So where you learn at Chapter 8, subtopic 8.3, refraction of light. Okay, so the law of refraction where we'll be going to apply today is actually you have already learned at the Form 1 Chapter 8. Okay, so there are a few terms not going to discuss again at Form 4 Physics. Okay, so where you actually need to know what is the meanings of the angle of incident. Okay, so where the symbol I is represented by angle incident. Okay, so angle incident is the angle between the incident ray and the normal. Okay, so from the figure here, you can see the incident ray will be the arrow strike to the plane mirror. Okay, and then will be reflected as a refracted ray. Okay, so here you can see there is the dashed line at the middle, which is known as normal. Okay, so the angle I will be the angle between incident ray and normal. Okay, so the incident ray is the ray of the light that strikes the plane mirror, will be showing with this arrow. Okay, and then the normal will be the line perpendicular to the surface of the plane mirror at the point where the incident ray strikes the mirror. So be this dashed line. Okay, so the normal line is drawn as a dashed line at 90 degrees to the surface of the mirror. Okay, so that means here the angle where the normal line to the plane mirror is 90. Okay. Okay, and then the refracted ray will be this. So it's the ray of the light that is reflected by the plane mirror. Okay, so the angle of refraction is using the symbol R here. Okay, so it's the angle. Okay, it's the angle between the refracted ray, where with this, and the normal. Okay, so this is the terms you actually already learned at Form 1, Chapter 8, and you will see again the terms in this subtopic 5.3. Okay, so the law of refraction, we have two important informations, okay, to remember back. Okay, so the first, the incident ray will be this ray, and the refracted ray, and the normal. So all lie on the same plane. So the same plane here referring to plane mirror. Okay, and then the second rule here will be the angle of incident, which is I, will be equal to the angle of refraction. Okay, I will be equal to R. Okay, so this is the law of the refraction, where will be obeyed by the light, where you learned in Form 1 previously. Okay, but for this chapter, we are going to learn the refraction of wave. So that means here, the difference here will be the light will be changed to wave. Okay, so the wave here can be light wave, can be sound wave, can be water wave, and electromagnetic wave. Okay, and then the refractor now will be uh, have the same function as the plane mirror you learn at Form 1. Okay, so let us go to detail okay, later on. Okay, and then the second is knowledge you learn at subtopic 5.1. Okay, so the first term here will be the definition of the wave front. So what is the wave front? Okay, so the wave front uh, is the phase where the locus or point vibrate in same phase. So for example, here we have the two type of the wave you learned already at subtopic 5.1. So there is the first one will be the transverse wave. So the transverse wave will be referring to the water wave, electromagnetic wave. Okay. Okay. So where the particles will be moving up and down and perpendicularly to the direction of propagation of the wave. So the particles is vibrate uh, vertically, and the wave will be propagate horizontally. Okay, so here you can see the crest will be the x1 and x2. Okay, so both of them is at the same phase. Okay, and then the trough will be at z1 and z2. So you guys say we look at the 3D dimension of the wave here. So here crest to crest here referring to wavefront. Okay, as well as the trough to trough also lah. Okay, and then the second one will be the longitudinal wave. So here we have the P1, P2 represent as the compression region, and the refraction represented as Q1, Q2 here lah. Okay, then the second you need to remember the type of the wavefront. Okay, so basically we have the two type of the wave already learned at subtopic 1.1, and we're using the Ripple 10 to observe the type of the wavefront. So firstly will be the circular wave. Okay, it's produced by the water. It's produced when water is disturbed by spherical dipole. You can see here is round shape. So the wave produced will be circular shape. Okay, and then the second will be the plane wave produced when water is disturbed by the vibrating bar. Okay, so here will be the plane dipole actually lah. Okay. Okay, so here the direction of motion of the water is always water wave line is always perpendicular to the wavefront. So you can see the wavefront will be here, here. The dashed line here showing the direction of motion of wave. So they are always perpendicular to each other. Okay, so this is also same for the plane wave. So the wave propagate showing by the dashed line, and then the black line here showing the waveline. Okay, so this is the knowledge you learned already at subtopic 5.1 and going to apply at subtopic 5.3 here. Okay, so here will be the wavelength between two consecutive wavefront. Okay, so you'll be applying when doing the calculation at learning standard for today's. Okay, so the next here will be how the dark and bright fringes are produced. Okay, so it will be like this. Basically, this is a plane wave. Okay, so you can see we have the bright fringes, and here will be the dark fringes. Okay, so when light transmitted through the wave, so here the light is actually okay. So this is the surface of the ripple tank, and the light will be from the top. Okay, so because you want to see the shadow form, okay, when we want to study the characteristic of the wave. Okay, so here the crest is actually represent as the convex lens. So you can see all the light will be converged together. So become bright fringes. Okay, then, okay, so we here lah, this line and this line, bright fringes. And then the parallel ray from light converges produce bright fringes. So as I mentioned just now, so all the bright will be converges, okay, at the crest, which act as the convex lens. So become bright regions. Then the next here will be referring to trough. So you can see the trough will be here, the lowest amplitude region. Okay, so the light will be, you can see, is diverge and form dark fringes. So the trough will be act as concave lens. Now you can see all the light will be diverges. So form dark fringes now. Okay. Yeah, so this is basically the knowledge you need to learn, okay, before you go to 5.3. Okay, so for your information, the worksheet for today's lesson you may download, okay, through the link here. Okay, I show you now already. Okay, so you can get the worksheet, okay, by using this link Please using MOE email to get through. Okay. Okay, so now let us go to our first learning standard. Okay, so in this learning standard, you need to know how to describe the refraction of wave from the following aspect. So that means when the incident ray hit the refractor, so they will be formed the refracted wave. So we need to see what's the changes between the incident wave and the refracted wave in the aspect of angle of incident. So I is will be changed. So angle of refraction, we want to see the relationship. Okay, as per mentioned just now, if let's say we obey the law of refraction, so the I will be equal to R for the law of refraction. Okay, so we want to study this. And then Z will be changed the wavelength. Then frequency, speed, as well as the direction propagation of the wave. So which will be changed after the refraction of the wave. Okay, so firstly, we need to define the definition of the refraction of wave here. Okay. Okay, so refraction of wave will be occur when incident wave strike the refractor and undergoes a change in direction of propagation. So that means here we are very clear that for the refraction of wave, the direction of the wave will be changed. Okay, so you can see from the GIF also. Okay, so the incident ray hits the refractor. So it will be change the direction. Initial will be go up, right? As this arrow, as well as the GIF also. And then after hit the refractor here, so the refracted ray change the direction to down, right? So that means here we are very clear that the refracted wave will be changed direction. Okay, so occur to water wave, sound wave, light wave, and electromagnetic wave. Okay, so just now I already mentioned to you, and Form 1 syllabus, you already know the light wave will be reflected. And also you learn already the characteristic of the sound wave during Form 2 science also, chapter 10. Okay, so these two type of wave actually already discussed, and the experiment also conducted during the PE3 level. Okay, so basically the reflected of wave, sound wave will be called echo, or you can hear when you scream, hit the wall, then you can hear again your voice return to you. So this is so called echo lah. Okay, and then light wave will be shown exactly like this GIF. Okay, you can see the light is reflected lah. Okay, and obey the law of reflection. Okay, and then here this figure will be have further discussion at the subtopic 5.6 and 5.7 here. Okay, so you can see here we have the radio wave. Okay, we have different type of radio wave. Okay, so here especially this type of radio wave, so will be reflected to the ground again through the ionospheres. Okay, so the radio wave will be referring to electromagnetic wave lah. So there are many types of the electromagnetic wave you are going to learn at subtopic 1.7. Okay. Okay, then the next here will be the activity you may find at the textbook page 189. Okay, so here will be the activity 5.11. Okay, we want to study the characteristic of the refraction of the plane wave. Okay, so here we want to see the refraction of plane wave. Okay, so as we know already just now, so we have two types of wave, where the first one will be a circular shape formed by the sphere steeple. So the plane wave will be formed by the plane steeple. Okay, here will be this lah. So we expected the waveform will be in straight line. Okay. Okay, so again, we're using the Ripple Dam to study the characteristic of the refraction of the plane wave here. Okay, so the figure here is the arrangement of the apparatus, which is exactly same as the formation of the plane wave and circular wave we discussed at subtopic 5.1 already. So different here is we just place the reflector here. Okay, so that the waveform will be hit the reflector and we want to see the effect. Okay, so the procedure will be like this. Right. The apparatus is set up as shown in diagram. Okay, so the ripple tank is filled with water. So here you need to fill with water lah. You can see here we have mentioned water already in the figure. Okay, and then the horizontal vibrating bar, okay, so with this is a plane tipple will be used. Okay, so it's lower until it touches the surface of water to create plane wave. Okay, to create a plane wave. Okay, so the plane reflector is placed in the water tank. So you can see will be this. Okay, so this will be the reflector. Okay. Okay, so then we want to on the lamp. Okay, lamp and motor lah. So the motor will cause the vibrating bar vibrate at the adjusted frequency. Okay, so the lamp here will be on the top, will be shine. So we can see the shadow form at the screen here. Okay, so the formation of the shadow, okay, it already discussed just now, right? We review again already. So the crest will be converge the light and form bright fringes, and then the trough region will be act as a diverging lens and diverge the light and form the dark region. Okay, will be this. Okay, so after the wave, the incident wave hit the reflector, so we want to observe the reflector wave by using the stroboscope. Stroboscope is here. Okay, last week I also discussed already how we use the stroboscope. Last lesson 5.1. Okay, so we observe the characteristic of the refracted wave through stroboscope lah, huh? Okay, and then the next here, okay, so basically you'll be observe this observation. Okay, so you can see here we have the bright fringes. Here is actually the incident wave. Okay, it's the incident wave, and you can see when hits the refractor, we have the also bright fringes at here, right? Okay, so here will be represented as the refracted wavefront. So you can see here the first three line here I draw. This is the incident wavefront. This is the bright fringes lah. Okay, and then when hits the refractor, so you can see the refractive wavefront is showing here already lah. I draw with red color line already. Okay, so from here we have to see the difference between the I and R. So where is your I? So be here. So this is the incident angle, and then R will be refracted angle. Okay, so now we want to measure. Okay, so this one will be see under stroboscope. So will be actually not so easy to take. Okay, so you need to take some time to get mark so that you can get the accurate result. Okay, so here you need to place. Okay, you need to place the corrector. Okay, so from here, you must make sure two line is draw. Okay, so here you can see. So firstly, place your base of the corrector 0 at the incident wave you draw. And then here will be the normal line. So which is 90 degree to the plane refractor here. So from here you can see it's about 41. Okay, so we expected the R will be 41 also. Okay, so next will be you have to measure the R. So again, you place a refractor at the end normal line, you can see. Okay, then you measure. Okay, so expected will be exactly almost the same here. Okay, if let's say we talking about the law of refraction here. Okay, so from here, we are clear that the angle I and R is the same. So this one will be obey the law of refraction. Okay, so this question you may get from textbook 180, 89. And then the next here, second question, we have to compare the wavelength. Okay, so here, after you mark when the stroboscope is turning, right? So the frequency must be same as the frequency of the water wave here, so that you may see the water wave is actually freeze ready. Okay, so you can mark. Okay, so then you measure the ruler. Okay, so here you can see two consecutive bright fringes here showing lambda 1. So the lambda 1 is actually the wavelength of incident wave. Okay, so about 1 now. So I just roughly give the reference answer only lah. Okay, so then the next here you need to measure the wavelength of the refracted wavefront here. You can see two consecutive bright fringes will be here. So this one will be referring to lambda 2. So this is the wavelength of the refracted wave. Okay, so you can see again, I get the almost the same 1 and 1 the wavelength for incident wave and wavelength here. Okay, so we can make a conclusion here. The wavelength will be unchanged between the incident ray and reflected ray. Oh, my sound got echo. Okay, wait. 有 sound 過 echo，誒唔係 sound 過 echo 啊。Okay, so is it still got echo now? Or better now? 小飞机 Okay, so please help to respond to me if I say they still have the echo. Okay, so yes sir, still got the echo. Okay, so wait Okay, so is it better already now? No still got echo Okay, wait me a while I try to do some adjustment. Oh, it's fine already. Okay, so good. Thank you for your response. Okay, so you helped me a lot. Thank you. Okay, so I already know I have no problem now. Okay, so let us continue. Okay, so you may join my discussion together. Oh, Shakashin. Okay. Okay, so we have already discussed just now. We measure both the wavelength here is actually the same, and we expected actually there is no any changes for the wavelength. Okay, can. Thank you. So, okay, so we continue the next question. Okay, so see here, can the stroboscope freeze the movement of incident wave and reflector wave here? Okay, so as I mentioned, so we need to turn our stroboscope. Okay, so you must make sure that the frequency, that means the spinning speed of the stroboscopes will be spin at the frequency same as the water wave. So you may see the water wave for the incident wave and the refracted wave actually will be freeze at the same time. So that means both of them have the same frequency. Okay, if I say two of the wave here is different, so different frequency. So when you turn your stroboscope at certain frequency, if you meet one of the frequency of the wave there, so another is moving, so they will be showing that the wave frequency will be different for the incident and reflected. But here, you will observe that actually the both incident wave and the wave reflected wave will be stopped at the same time. So this showing that both of them will be have the same frequency. Okay, so you can see this is the way how we use the stroboscope. Okay, last week actually I also show you already. So you must turning your stroboscope and look at the slit. Okay, you must look at the slit. Okay, so when you look through the slit, so the wave expected for both incident and reflected is actually stopped at the same time. Okay, where showing that both of the wave is actually have same frequency. Okay, so here, yes we see both of them will be stopped at the same time. Okay, and then based on your answer in question 3, compare the frequency of the incident wave F1 and the F2. So they will be the same. Okay, so F1 equal to F2 Okay, so then the last here will be for your answer in 2 to 4 will be here. 2, 3, and 4 here. Okay, so compare the speed of the incident wave V1 and V2. So the V1 will be the speed for the incident wave. V2 will be the speed for the refracted wave here. Okay, so we learned already this formula. V equal to F lambda. Okay, so from the answer number 2, you can see the wavelength is same. And then from number 3 and number 4, we can know that the frequency is also the same. So that means both refracted wave and the incident wave will be have the same speed. Okay, so this is the discussion at the textbook regarding this experiment. Okay. Okay, so here we can conclude that this is the characteristic of the refraction of the wave. Okay, so through the experiment, we can know that the I, the angle incident, is equal to the angle of the refraction. So first, I equal to R, which obey the law of the refraction. Okay, and then the wavelength, just now we measured through the discussion, question number 2. Okay, so both will be also no change here. Okay, so both will be same incident wave and the refracted wave, both the wavelength will be the same. Okay, and then the next here will be frequency, also the same. Okay, we use stroboscope, okay, spinning at the same frequency with the both of the wave. So we observe that both wave will be freeze. That means not moving. So that means both of them will be have the same frequency. Okay, and then the speed will be also no change through the formula V equal to F lambda. Frequency same, wavelength same, so the speed of the wave will be also no change. Okay, so the change will be only the direction. So you can see incident wave hit the refractor will be change direction, but according to the law of refraction, where I and R will be the same. Okay, you can see the answer here. Changes with the condition that the angle of incident is same as angle refraction. Okay, so this is the discussion and the conclusion we can make for the characteristic of the refraction of the wave when to meet the learning standard 1. Okay. Okay, then we go to the learning standard 2. Okay, so for those just joins the class here, so you may download my worksheet through this link with MOE email. Okay, you can straight away get the worksheet. Okay. Okay, so the learning standard 2, you need to know how to draw a diagram to show the refraction on plain water wave by through the plane refractor. So you can see we want to know how to draw the refracted wave, okay, by using the plane refractor. So the syllabus here we discuss about the plane refractor. Okay, so here actually I take the method from the textbook. Okay, so you can see here will be the wave front of the incident wave. Okay, so how we can draw the reflected wave? Okay, normally will be come out at the question section A, ask you to draw. Okay, so thank you all, Sakihin, okay, for supporting me. Okay, so I hope that you keep together with me and show your response in the chat room. Okay, so that I know you're learning with me. Okay, so here you can see the first step will be draw the arrow of line AB. So the AB line here will be the incident wave. So be this. Okay, so how we can draw this? You can see to represent the direction of propagation. So here the AB line must be perpendicular to incident of the wavefront. So the wavefront will be blue line here. Okay, so the angle here must be right angle. Okay, so the right angle is here. Okay, so that means your arrow here for the incident ray is correct already. Okay, then the next here, the step 2, draw the normal BN, which is perpendicular to the plane refractor. So that means you need to draw, and here represent the normal line. So here will be 90 degree to the plane refractor. Okay, and the next, you need to measure the eye through the protector. Just now I also show you already how to measure. Okay, so the step 3, draw the BC line with the condition of CBN. CBN will be somewhere here lah. C will be here. Okay, will be same as ABN. So ABN will be angle I lah. Okay, so now we need to draw the BC. So that means here you need to place your protractor here. Then the angle here R must be same as I lah. Okay, so I show you just now already. So the method will be the same. Okay, so the line will be expected here where the angle R and I will be the same. Okay, so this will be angle NBC here lah. Okay, and then the next will be step 4, draw line perpendicular to BC. Okay, so that means we need to draw another refracted wave lah. Refracted wave front. Okay, so must be perpendicular to line BC here. Okay, so be here actually. Okay, perpendicular, that means here must be 90 degree. Okay, so here you can see the information at bracket here. Okay, so the refracted wave, the wavelength, lambda 2 must be same as lambda 1. Okay, so the lambda 1 will be here. Here, 2 consecutive incident wavefront here. And then the wavelength 2 here represent the wavelength for refracted wave. Okay, so the both must be the same to meet the law of the refraction. Okay, so this is the way how we draw. Okay, so now let us go to checkpoint 5.3 question number 1. Okay, so here complete the diagram below by drawing the wave front to show the refraction of the water wave. Okay, so you can see this is the question. Okay, so here is actually the example here is exactly same as the activity 5.11 just now we discussed. Okay, so here this is the incident wave lah. Okay, so firstly we need to measure I. So you must place your protractor here. So you must measure the angle here. Okay, so here you may get about 45 degree actually. So this is the first method. Okay, and then the second, you must make sure this one was the same as R. Okay, so here, okay, so we place protractor here. Okay, so the angle we measure here must be same as 45 lah. Like say just now I mentioned here, I is 45. So here also must be 45. So we get this line. Okay, after we get this line, we need to draw 3 lines as the refracted wave. So again, just now I mentioned here must be 90 degree. And then the wavelength 2 here must be same as the wavelength 1 here. Okay, so this will be the answer lah. Okay, so let us go through the answer together. So we measure I. Second step, draw refracted line where the angle R and I will be the same. So then you draw this red line, red arrow down here. Okay, and then the next will be draw the refracted wavefront. Okay, so 3 lines lah. And make sure the wavelength for both lambda 1 and lambda 2 will be the same. Okay. Okay, then the next here will be B. Okay, so B here will be, you can see the incident wave here straight away hit the refractor. So the incident ray is parallel to the refractor. Okay, so here, this is the GIF you can see. So here, middle here is actually the refractor. Is refractor. So you can see when the wave hit the refractor, so they will be straight away the reflected wave respond at opposite direction. Okay, so this one, the figure GIF here is quite fast lah. Okay, so what you expected to see is actually like this lah. Okay, so here, draw reflected line. Okay, so here will be the red arrow. So it's opposite. Okay, you can see when the incident wave hit the reflector, so the reflected wave will be at the opposite direction. Return back. Okay, return back here. Okay, and then draw the reflected wavefront which is perpendicular to reflected line. So we with the red line here. So the blue line will be the reflected wavefront. Okay, you can label lah for your answer and make sure the wavelength. Okay, so first must be perpendicular. The wavefront reflected wavefront here must be perpendicular to the direction propagation of the reflected wave. Okay, then you need to label at your answer. Reflected wave is which line? Okay, and make sure both consecutive line, the distance here, lambda 2, will be same as the incident wave wavelength. Okay, so this is what you can draw for this question. Okay, so the next here will be the concave barrier. So this one will be the spatial question here. Okay, so when you see the GIF here, okay, you can observe the GIF. You can see when the wave hit the concave barrier here. Okay, so you can see this. Okay, so this is a plane. Okay, when hit, you can see there is a circular reflected wave. Oh, you can see again when hit. Okay, form circular wavefront. Okay, so the answer will be like this. Okay, so here the red line is the incident wave, which is a plane wave. Okay, you can see here this is the plane dipole lah. So for sure will be form the here the plane wave, and then when hit the concave barrier will be form the circular reflected wave lah. Okay, so here reflected wave propagate as a circular wave. Okay, from a single source F in all directions. The single F here, that means here will be like a circle. So the center will be labeled as F here lah. Okay, so when the incident wave hit the reflector, so they will be returned as these two arrows I draw in blue. Okay, and then they will be the circular waveform. Okay, will be like this. The black color line here showing this is the reflected wave, and here you can see I mentioned lambda 1. So that means here lambda 1 is a wavelength of incident wave, must be same as here lambda 2. All must be the same for the reflected wavelength. Okay, so this is the reference answer for this question. Frequency is vector or scalar? Okay, so frequency, the formula for frequency is 1 over t. T is the time. Okay, so the time is scalar quantity. So the frequency is also scalar quantity. Okay. So Shakahin, okay, so the frequency is actually the scalar quantity. Okay, so I hope I answer your question. Okay, so thank you, Cikgu Hasnitah, for joining my class. Okay, so thank you for support. Okay, so now let us continue. Let us continue the next question. Okay, so here is question number 2 is a question from 2019. Okay, so you may show your answer. Okay, at your chat room. Okay, Shakahin. Okay, so here, which of the following diagram is correct to show the reflection of the wave? water web. Okay, so when we see the refraction here, that means we need to obey the law of refraction. Okay, so here the first will be I and R must be the same, or incident angle and the refraction angle must be the same, and then wavelength must be unchanged, frequency must be unchanged, wavelength must be the same. Also, okay, so wave speed must be same. Okay, so the Shakiran gives C. Okay, so answer is actually correct. Good, Shakiran. Okay, so here the change will be the only direction. Okay, so the A is wrong because you can see the wavelength lambda 1 and lambda 2 here is different. Okay, so B is also wrong. You can see very clear. The lambda 1 too big is longer, lambda 2 is smaller, so it's also wrong. Okay, so the C is correct. Okay, so good. Shakahin. Okay, so the wavelength you can see here both is the same. Okay, second you can see the direction here. Direction propagation here, I and R is actually okay. The reverse already. Okay, so here you can draw the normal. Okay, so here is incident ray. So here will be I, and then here will be R. Both actually the same. Okay, so the answer is actually C. Okay, so here you can see although the wavelength is same, but the direction is not the same. The angle I and R is different. Okay, so answer is very clear, will be C. Okay, so we go to the next question. Okay, so question number 3. Okay, so you may show your answer together with me again here in chat room. Okay, so the diagram 17 shows an apparatus set up to investigate the refraction of the sound wave. Okay, so this is a sound refraction where actually you learn already at Form 2 Chapter 10. Okay, so this topic is actually quite related to sound refraction where you learn already at the Form 2 syllabus. Okay, so the condition, which condition is correct about for this experiment so that the students can hear the sound of the stopwatch clearly. Okay, so here, firstly, we need to know that this is a reflection of sound, and the reflection sound wave obey the law of reflection. Okay, so this is the first. Okay, so I and R will be the same. So that means C and D might be correct. So you may show your answer at the chat room, and so that I know you're learning together with me. Okay, then here the next will be the student must be here clearly. So here we get 2 types of surface we need to identify. So the X here, we want the sound to hit the reflector, right? So the reflector will be hard and smooth surface. Okay. Then the Y here, we can see the stopwatch is here. So we do want the sound to pass through the next tube here. So that means the Y must be the material where can absorb the sound. Okay, so absorber, good sound absorber will be soft and rough surface. Okay, so here we are very clear. The X will be hard surface, will be polywood, plywood here. Okay, plywood. Okay, and then the Y must be soft board. Okay, so good. Okay, so I can see the answer from Shakahin. Okay, so answer is D, is correct. Okay, so very good, well done. Okay, so thank you, Cikgu Hasnitah, okay, for supporting me. Okay, so here, okay, so before we go to our learning standard 3, okay, so I think we can take a short break. Okay, so later on we can continue learning standard 3 and learning standard 4. We still have 2 learning standard are going to learn later on. Okay, so please stay together with me. Okay, around 2 minutes. Okay, so welcome back. Okay, so now we are continuing the next learning standard. Here, the learning standard 3. Okay, so here you must able to justify the application or reflection of wave in daily life. Okay, so now we want to know how to apply the characteristic of the reflection of wave you already learned at the learning standard 2.1. Okay, so here we have total about 5 applications going to discuss here. So the first here will be the ultrasonic wave. Okay, so this actually is also the knowledge you learned already at the Form 2 syllabus. Okay, so I will go through quite fast here. Okay, so ultrasonic wave is used in medical field to scan structure of the internal organ in human body. So you can look at this figure. Okay, so normally we want to do the checkup. We can see the inner, the fetus is in the healthy condition or not by using the ultrasonic wave here. So the ultrasonic wave is actually the sound wave which is above the range of the sound range where able to hear by the human. So the normal range will be 20 hertz to 2000 hertz. Okay, sorry, is 20,000 hertz actually. Okay, so that means here when the sound ultrasonic wave here will be above the normal range of human, okay, which is above the 20K here. Okay, so the ultrasound will be reflected and form the image of the contrasting brightness. So be almost like this. Okay, so you can see the dark region and the bright region at this picture. Okay, so the dark region here, okay, is actually showing this is a soft tissue. Okay, because the soft tissue is the parts where able to absorb more incidence of ultrasound and reflected very little. Okay, so that means the transducer here will be receive little reflected ultrasound. Okay, when touch the tissue surface. Okay, and then for the bone surface, which is harder, so the parts will be reflect more ultrasound. Okay, so the transduction will be have the different intensity of the ultrasound will be received, and this one will be and then will be analyzed by the computer lah. So we count this picture lah. Okay. Okay, then the second will be application at the submarine. Okay, so you can just look at the figure here. So the submarine able to detect the obstruction, okay, under the sea here. Okay, so the submarine can detect the depth, obstruction, or structure of the rock in the sea by refracting wave. So that means here the wave will be sent out from the submarine. Okay, when the submarine receive the refracted wave in shorter time, so that means in front there will be have the obstacle. Okay, so they can change the direction to avoid any accident will be occur lah. Okay. Okay, then the next here will be the application of radio wave lah. So here you can see the radio wave we use in telecommunication field. Here we're using the parabola antenna. Okay, so the reflected wave received will be focused at this point. Okay, so this will be the reflection of light. Okay, will be have further study at chapter 6, subtopic 6.6 here. Okay, then the next will be the navigation of the bat in darkness. Okay, so how the bat can navigate in the dark. So the bats actually cannot see anything. So but their response is very fast. Okay, so how they can do that? Okay, so they're actually using the ultrasonic wave also lah. Okay, so they will scream. Okay, and the sound will be hit the obstacle and then return to the ear of the bat. Okay, so if I say the return duration is very short, so that means the obstacle is just in front. Okay, so the bat will be able to change its direction. Okay, and avoid from injuries lah. Okay, so this is the detail. Okay, so a bat generate ultrasonic wave when moving in the dark. So the ultrasonic wave hit the wall and are refracted to the bat, the ear of the bat. Okay, so this enable the bat to estimate the distance. Okay, as I mentioned just now, if I say the return time is very short, so they will be the obstacle will be very near lah. Okay, so this enable it to avoid hitting the wall. Okay, so this is the fourth application. And then the fifth will be the sonar technology. Okay, so here, sonar technology is used by most ships to detect area with large numbers of the fish. Okay, so you see here. Okay, so we use technology to know where the region have more fish now. Okay, so they can get more fish production here. Okay, so the transduction transmit to the wave into the water and is reflected by the fish back to the transducer. Okay, so here is transducer. Then the next here will be pattern of the reflected sound wave caused by different rock enable the location and the depth and the structure of the seabed which contains sources of natural gas to be identified. Okay, so here that means we can use sonar technology to measure the depth of the seabed. Okay, so the depth of the seabed can be calculated with this formula. Okay, so this is the depth D. Okay, so by using this formula Vt over 2, this is the formula you also learned already at Form 2 actually. So the V here referring to velocity of the sound in the water, and then the T will be the time interval. So that means the time will be go down and then go back. So we are actually measure 2D. So with the formula, speed equal to distance over time. So the distance here we're using 2D because we measure go down and then return again. Okay, so D, so S is referring to D, speed V lah. Okay, so V equal to 2D divide T. So D will be Vt over 2. So this is how the formula come from. Okay, then the next, we go to our last learning standard. Learning standard 4, so solve problem involving refraction of the wave. Okay, so here will be the question. I take from SPM 2006. Okay, so let us read the question together first. Okay, so diagram 21 shows the submarine transmitting ultrasonic wave directed to a big rock. So be here. Okay, so after 10 seconds, the submarine detect the reflected wave. So that means the sound is actually go hit the rock and then return. Okay, so calculate the distance. So we are very sure that we will be applying the formula just now I show you. Okay, so it will be from here we're using D equal to Vt over 2. So the V is given by the question already. So it's the velocity of the ultrasonic wave in water, which is equal to 1560. And then the time taken here will be 10 seconds. Will be this. So we just substitute to the formula and then we get the answer. Okay, so the answer here will be B lah. Okay, can. Okay, so you can also show me your answer together. Okay, at the chat room. Okay, so that I know you are learning together with me. Okay, then the next here will be the question number 5. This one is a question from 2010. Okay, so the question will be like this. Diagram 28 shows how the reflection of sound wave is used to find the depth. Okay, so this is exactly same with the application of technology sonar just now I explained. Okay, so we have to find the D here. Okay, so what is the depth of the wicked ship? Okay, wicked ship is here. So we have to see where is the location lah. Okay, so the sound will be sent out and then return again. So here taken 0.2 second. Okay, 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 so you may do together with me for this question. Okay, so here again you can see we actually want to get the depth. So that means we want to get a D. Okay, so what is D here? The answer. So we are very sure will be using the same formula. Okay, so here the question given us the velocity. Okay, so the velocity will be 1530. Or again, then the time taken here will be 0.2 seconds. Okay, we're using the information given, substitute. Okay, so what is the answer? Okay, so again, substitute whatever the value given here. Okay, you can see the SPM question is actually not very hard. Okay, we just substitute the value given in the formula. Okay, so here we'll get 153 meter. Okay, so I hope that you also get this answer. Okay, cakahin. Okay, so answer here will be very sure is A lah. Okay, then the next will be our last question. Okay, so this will be the partial question from 2014 section B, which is related to this topic today lah. Okay, so you can see here is a bat, okay, using the ultrasonic wave to navigate. Okay, so here diagram 12.1 shows a bat using ultrasonic wave to detect obstacles. So the obstacle will be this in front of it. Okay, so what is the ultrasonic wave? So just now I also give the definition already. So we have the range, normal range of human is 20 to 20,000 K. 20,000 K hertz. Okay, so the sound where above, okay, so where above 20,000 hertz referring to ultrasonic sound. Okay, so how about the sound is below 20? So if I say below 20, we know as infrasound. Okay, so this you learn already at Form 2 actually. Okay, so the definition here will be the sound wave with frequency existing 20,000 hertz. Okay. Okay, then the next here will be the explain. You need to explain how the ultrasonic wave are used by the bats to detect the distance of the obstacle. Actually, just now we explained already. Okay, so here 4 marks minimum. You need to give 4 points here. Okay, so I advise you to give more than 4 points because sometimes the answer you given will be different from the scheme. Okay, so to meet more answer, where can follow the scheme, so you can give maybe 6 points, but here you are not allowed to give control answer lah. Okay, so the first point advice here will be bats detect the distance by using ultrasound. Okay, so this is the first point. The second here will be detect the distance by listening the echo. So the sound produced will be go in front and then reflected to the ear again here. Okay, just now I also explained already. Okay, then third mark here will be the period of time between sending and receiving of the ultrasonic wave is noted. The distance can be estimated. So let's say the time taken to receive the sound very short, so that means the obstacle is very near already. Okay, and vice versa. Okay, so here will be the point where just now the note is not included. Here will be bats can detect ultrasonic sound of 75,000 hertz here. Okay, so this is another additional point you can take note here lah. Okay, then we go to the calculation. We left another 2 calculation. Okay, question at the classic question of 2014 here. Okay, so here will be the calculation. Okay, so a beam of the sonar with speed of 1,450 be here. Okay, send out to a school of fish, a school of fish. Okay, underneath a fishing boat. Okay, so calculate the depth. So again, we need to calculate the D here. So that means we apply the one and only formula we learned just now. Okay, so the time taken here for the echo to be received is 10 milliseconds. Okay, so here you can see the unit for the speed is meter per second in SI unit. Then the time taken here milliseconds. So that means here will be not SI unit. So the 3 marks here, the first mark will be given for the changes of the unit from millisecond to second. Okay, so this is a D lah, we want to measure and we want to calculate. Okay, so here question given us T equal to 100 millisecond. So the first mark here is actually you need to change to SI unit. Okay, then the next given info here will be V equal to 1450. Okay, then we substitute in the formula. So we get 72.5 meter here. So the substitution will be second mark. Okay, so here the answer we correct unit will be third mark. So normally we are given minimum 2 decimal places here, but because of the exactly value, so 1 decimal place here is accepted. Okay, 3 mark will be this. Then the last question here will be the wave of the sonar when its frequency is 40 kilohertz. Okay, so this one will be used another formula we learned already at the previous subtopic 5.1. So the wavelength and the frequency will be related to the speed. Okay, so the formula will be this V equal to F lambda. So we substitute F equal to 40K. So make sure your 40K is 40,000. You need to change your K to another 30 here. Okay, so we want to get a wavelength. So we use this formula. We rearrange again. So we substitute V and F. So the question given us F equal to 40K. So that means you need to change to 40,000 here. Okay, and then the V given here is 1,450. You just substitute, then you get your answer. So here will be 0.03625 meter. This is exactly value we get. Or you can give minimum 2 decimal places where 0.036 meter is accepted also. Okay, make sure you give. This formula will be given in exam. Okay, so this one I need to check again the formula list. Okay, but this V equal to F lambda will be given. Or this one I'm not so sure, but just now I show you how to derive the equation already, right? So this formula is actually come from speed equal to distance over time. So as per mentioned just now, the time taken is go down and receive again. So the distance traveled here referring to 2D lah, and then the time taken we still maintain as D. So V equal to 2D over T. So D equal to VT over 2. Okay, so I think this formula is not given. Okay, because we can derive ourselves here. Okay, but V equal to F lambda, I sure that is can get from the formula this lah. Okay, so I will recheck. Okay, and send again the comment in this video later on. Okay, maybe you can return and see again. Okay, so thank you for you to continue support me until now. Okay, so that's all for my sharing today. Okay, so thank you lah, especially the Shakahin. Okay, so to follow me until the end here. Okay, so this is all the sharing about the subtopic of today. Okay, so please click like, share the link of the lesson of today to your friends. Okay, so that more students will be gain the benefit from the sharing of today. Okay, and don't forget to follow our next physics classes, which are every Friday for the Form 5 Physics, okay, 9:30 p.m. Okay, so the next topic will be regarding the 6.1. Okay, so will be the radioactive decay. Okay, it's chapter 6, nuclear physics. Okay. Identify. Okay, so can tell how to identify the scalar and the vector. Okay, so here, so for example, okay, so I give you a very easy example, Shakahin. Okay, so the scalar quantity is actually referring to the quantity which only have magnitude. Then another one is vector quantity is have the magnitude with direction. So what means by magnitude? That means we have the value. Okay, so here I'm using example. So we have the distance and the displacement. Okay, so the distance, for example, here I have a route, a person here running from point A to B. Here A and B. So maybe 10, I just give a 10 meter, for example. And then we go to C. Here we have another 5 meter here. Okay, so and then the person return back to B. So from A to B, then to C, return back to return back to B. Okay, so the distance will be 10 plus 5 plus 5, which is 20 meter. Or then we not need to mention any direction. But for the displacement, so we just need to know the initial position and the end position. The first position will be A, ending at B here. So that means here will be only 10 meter. So the answer here will be 10 meter, but you need to state the direction. So you can see the person is returned back to original position. So where will be the left here? So you just mention 10 meter to left. Or to original position also can. Okay, so another example will be velocity and also the speed. So the speed will be scalar. So we don't need to know the direction, but the velocity, we need to know the direction. Or Shakahin, I hope that I answer your question. Okay. Any question again? Okay, so I hope that the lesson for today's able to benefit more students here lah. Okay, so any question you can just leave your comments, okay, at the chat room. Okay, so thank you also lah, Chakahin. Okay, so I hope they continue to support our physics team in Akademi Youtuber. Okay, so I think that's all for my sharing today. Okay, so bye bye and see you all another lesson lah. Okay, so next week will be have another 2 lessons where the physics form 5 will be presented by Cikgu Rosemawati. As I mentioned just now, we continue 6.1, and the form 4 class will be presented by Cikgu Hasnitah. Okay, so the Cikgu Hasnitah will be continue the subtopic 5.4, reflection of light. Okay, so see you all again. Okay, another lesson. Okay, bye bye. See you.